Hi, this is Phil Kerner, the Tool and Die Guy, with another real-life manufacturing lesson. This is one part, 13 setups, believe it or not. So let's take a look at this part. Um, you know, I'll go through it in the video, but this is pretty much the finished part. And this comes to me as a burnout. And just picture this part with all this stuff not being cut. Just a 4 by 4 inch square piece of steel. And I'll go through how I asked them to finish this stock to me, because the first time they tried to do it, they lasered or plasma cut all this stuff out, and it was impossible to hold on to. So again, obviously, you'd probably be thinking, why wouldn't you just wire EDM this out? And it's not a bad solution. We don't have a wire EDM. Unfortunately, wire EDM is quite expensive. So let's go through this lesson. I hope you learned something from this, and let's get started.
No intros. Let's just talk about this real life manufacturing experience that kept me very busy this past week. You know, when you first look at this part, doesn't look like a lot, does it? This thing is basically 3/4 of an inch thick, and it's 4.156 from here to here and 4 inches here. Now, they painted me into a corner when we first got the material, and what they thought they'd do is do me a big favor, see, is they gave me the stock. They plasma cut it out and left me a little material on it. So they burned these out of solid plates. They walked around and burned all that out. Well, not good. I really didn't have a way to hold on to it, did I? Because I would crush what was here. So after a couple of days of screwing around, I said, this is getting nowhere. And the biggest challenge I had was this hole. This is a 5/15 diameter hole that goes all the way through the part. And they want it positioned within 0.003 of an inch, and it's not normally a huge deal, although if you walk at all, it's gonna, you could screw this up. But imagine trying to drill through here, then your drill starts over, drills through here, and then starts over. Now, the only thing I could have tried, which I still don't think would have worked, is to drill through this part, center drill here, drill through here, bring the drill back out, center drill here. And I just didn't like it. So I convinced them, here, cut the material over again and cut it out of 1 inch stock. That'll give me a 1/4 inch to hold on to the back of the part. And then I can go through it. So let's go through this. Believe it or not, I think there's like 10 or 12 operations on this. So what I did is I said, take the 10 parts down to the Blanchard grinding department. Just skim both sides. Don't worry about the dimension. Just skim them off so I have something flat to start with. That way I'm not wasting my time cutting 10 blocks flat when a Blanchard grinder can do it all 10 at once. So that didn't take them long to do it all. So I get these 10 parts, now they've been Blanchard ground. So the first thing I had to do was stand them all up in my vise like this, and I cut this side, and I flipped it over, and I cut this side to establish my 4 inch dimension. Then I laid them down in my, the picture, this is still a solid block of steel, right? Then I laid them down and milled these two sides to get the 4 inches 156 dimension. So now I've got a block, or 10 blocks of steel, that are flat, parallel, because we had them Blanchard ground, and now they're square, and they're 2 dimensions. So we've established the overall dimensions except for the thickness. While I'm still solid, though, I stood them up and drilled and reamed this hole all the way through, and they came out perfect, size-wise and location-wise, from end to end. They're within 1/1000th. Mission accomplished. While I was still set up, I went around and milled this radius, flopped them over, milled this radius, and drilled and reamed this hole. All right, so now that's done. Next up on the agenda was I set it like this in my vise, and again we're talking a solid piece here, okay? It's solid. And I came in and wrote a program to go in and cut all this stock out. And I came in over here, cut this radius, and milled all this stock out. And finished all that stuff, except what did I end up with? Because I went in here with I believe a 1/2 inch end mill. I have a 1/4 inch radius now in all these corners. 1, 2, 3, 4. So we get to that point where we're happy with all our dimensions, we're good to go, and I still have a 1/4 inch of stock on the back side. Well, now that has to come off. So next we're going to flip this over. I went this way, 180 degrees, and came through with an end mill, and picture there's a 1/4 inch top hat on this whole back of the part, and I knew what was going to happen when I started milling it off. That 1/4 inch was going to, the closer I got to finish, you get that little 30 thousandths left, and it starts flopping around and kicking. Well, it did, and it moved one of the parts, didn't ruin it. So what I decided to do was take a pass and go through here. They stayed 50 thousandths away, and all we had left then, it cut all that excess, that top hat off, and now I just had basically 250 thousandths on this whole area to come off. And then I just said to hell with the 3-inch face mill, because I was still afraid it was going to make the part jump. So I just came through and cut it with the top of the bottom of a 1/2 inch end mill, and they came out perfect. It takes a little longer to do it that way. They came out good. So now we've got the part flat. Next, we have to stand it up in our vise, and we have to pick out this corner and this corner. Then we have to turn it around, stand it up again in our vise, and cut this corner out and this corner. So now that's done. Then I had to stand it up and machine this 45-degree angle on, turn it around, machine this 45-degree angle on it, turn it around, machine this 45-degree angle on it, and turn it around and machine this 45-degree angle. You could not do two at once. They're all going in opposite directions. Meanwhile, not only so this was finished when we were laying down all these dimensions. Every time I stand this up, whether it's to pick out these corners here, I've got to blend, right? I can't be banging into these walls. I've got to blend there and blend there. Then when I stand up in 45, I've got to blend there and blend there. Then when I stand up in 45, I've got to blend there, blend there, blend there, blend there, and blend there, blend there. I mean, okay, done with that. Last thing I did was set it up, and like this, just like that, and machine these two 45-degree chamfers on it. So I keep losing count of the amount of things we did on the setup. So if we say 1 was establishing the 4-inch dimension, 2 was establishing the 4 inches when we came through here, 4 inches of 156. 3 is drilling the holes and cutting that. 4, putting that radius on. 5, laying it down and machining the profile. 6, milling off the backstock. 7, picking these corners out. 8, picking these corners out. 9, 10 for that 45. 11, 12, the 45s, and finally 13 was to put these two chamfers on here. There you go. They said they lost their ass on this part, and I said, did you quote 13 setups? Probably not, and they didn't. So there you go. That kept me busy, and you look at a part like this, it's like, oh yeah, whatever, it's some sort of pivot, right? You got a dowel pin here, and who knows what it does, but it doesn't look, but people forget there's tolerances here, right? +3 minus nothing, +1 minus nothing, plus nothing minus 3. I mean, so you've got a lot of flexing going on here, and one of the biggest problems I had, of course, when I had to mill that stock off the back, I had to put jack screws in here because I didn't want to squeeze the part. Then why didn't I hang on to it like that? Because every time I closed the vise, it kicked. It was a lot. So I hope you learned a little something there. Anyways, a real life manufacturing experience that gave me some good challenges this past week. And I am going to talk to you a little bit about this plate on my next lesson. I've got a bunch of these plates laying around. Let's back this up a little bit. 5x7 plate, basically. They cut a bunch of material off wrong years ago, and we saved that skid, and I use these plates for little fixture plates and stuff all the time. So what I ended up doing to cut these 45s here is I put this in my vise, tipped it up on 45 degrees, and I had to figure out a way to clamp it. Well, I had a hole there, I put a clamp over it, then I had to turn it around. I think on this one, I clamped through that hole there, and then when I did this one, let's see, I think that's where I used that hole, and then I had to turn it around, and I think I used that hole again. So it worked, but I'm going to talk to you in the next video about a little better solution. So let's get to that one in a second.